Okay. Is it visible the PPT?
Yes, sir.
Yes, sir. And board, Microsoft Whiteboard.
Yes, sir.
Yes, sir.
Okay. So in the previous class, I was covering the addition of two images. So I just want to show. Okay. So I have started the arithmetic operation, and there are some important points which you have to remember. I have also explained, and we have also used these important points during the addition of two images. Okay, that if the result is floating point number, then round off its value. If the result is above the pixel range, select the maximum range value, and if the result is below the pixel range, select the minimum range value, and the last condition, that is for 0. Okay, now I am skipping this arithmetic operation. I have started represented some difference, multiplication and division in terms of f of x plus g of x. Now I have covered. So up to here, if any student have any doubt, then please you may ask. I have covered it also with the help of MATLAB course. Okay, now this is the MATLAB code. I am adding a function to two images. Now see here, this is the example at array. So this is the assignment for you, that you all students have to create two arrays. One is x and another is y. Okay. Now this I have created of 3y this in this way. So you all have to create two array x and y of 3y3 matrix. Then apply the IAM function. Okay. Now I think you have performed in the lab also this part. So up to here, is there any doubt to any student? Please आप बोलते जाइए.
No, sir.
Okay. So up to here, you have no doubt. Okay. So in the previous class, while I have started the arithmetic operation, then I have given that this is the addition process which is used for the reduction of noise. Okay. So this is the example here, which is to support the statement. Suppose this f of x comma y, it is your image, and this n of x comma y, it is the noise. So this, if the noise is added with this images, then we obtain g of x comma y, and it is the corrupted image. Okay, it is the corrupted image. Now the objective of the following procedure is to reduce the noise content of the output image by adding a set of noisy input images g I x comma y. So हमारा यहाँ ये पर्पज है कि जी आई एक्स कॉमा वाई जो आपकी इमेज आएगी करप्टेड, यहाँ पर 1 हो सकता है, 2 हो सकता है, 3 हो सकता है, 4 हो सकता है, इनको हम ऐड करेंगे, एंड दिस एडिशन लीड्स टू इंक्रीज द image quality, or we can say this technique is used frequently for the image enhancement. So here this is g bar of x comma y. It gives the average of this image for I equal to 1 to k. यहाँ पर I equal to 1 to k means k if it is 10, if there are 10 noisy images or 10 corrupted images, then 1 by 10, and you will add all the first image, second image, third image, fourth image, fifth image, sixth image, 7, 8, 9, and 10, and you will divide it by 10, and you will get the average. Then this E of g bar x comma y, it is equals to f of x comma y. Then the expectation of this complete will give the input image which we have initially, this f of x comma y. Okay. Now this E of g bar x comma y, it is the expected value, and these two sigma square for noisy image and this g are the variances of these two types of noises. And you can also calculate the standard deviation. It is 1 by square root of capital K sigma x comma y. Okay. So the important point we have to remember that as b added simple as b added the noisy images, okay, then b move towards the noiseless image, that is f of x comma y. Okay, or we can say as the k increases, it indicates that the variability of the pixel value at each location x comma y decreases. Okay, because the expectation of g of x comma y it is equals to f of x comma y. This means g of x comma y approaches the noiseless image. That is the our input image. So see the example. This is the major application of this is the that it is important application of image averaging is in the field of astronomy. Okay, so this is the image averaging and it is very much useful in the field of astronomy. So you can understand it with the help of an example. See, this is one image, astronomy image, second image, third image, fourth image, fifth image, and sixth one image. Now here we have added, see, 5, we have taken the average of 5 noisy images. Second one, we have taken the average of 10 noisy images. Third case, we have taken the average of 20 noisy images. Fourth one, D, we have taken more number of images, average. Now, in this way, in the last image, we have taken more number of images and we have calculated the average value. So it is clear, it is very much clear in this last figure, that is the F figure. Okay, यदि आप ज्यादा से ज्यादा नॉइजी इमेज का एवरेज निकालते हो तो आपको जो इमेज मिलती है it is towards the original f of x comma y, or we can say this averaging of the noisy images increases the quality of image. Is that clear? किसी को कोई डाउट है क्या इसमें?
No, sir.
Okay, so this is the example which I have covered to justify the statement that it is used for the reduction of noise. Okay, now I am going to start the subtraction operation. So subtraction is used routinely for enhancing differences between the two images. It is often used to detect difference between two images. Suppose if there are two images x and y, then you can obtain the difference between these two images. Then subtraction operation is useful. Okay, so such differences is it visible? Font size sufficient है? Abhishek?
Yes, sir.
Okay. So the main point for the subtraction operation is that it is used to detect the difference between two images. So such differences may be used for several factors such as artificial addition or to removal of relevant contents from the images using an image manipulation programs. And relative object motion between two frames, you can also use this of a video sequence and many other applications also. So subtracting a constant value, or we can say scalar value from an image causes a decrease in its overall brightness. आप यहाँ पर constant value की बात कर रहे हैं तो ये 5 हो सकती है या 10 हो सकती है. So, okay, a process sometimes referred to as the subtractive image offset. Now second point, subtraction is used to identify the difference, the pixel contents from the two images, or subtract a constant value to pixel values of an image. Subtracting the contents of two color images results the difference when x and y are 2D array of the same size. So this is the just simple example. Here this is your first image, this is your second image. In the we have subtracted these two, then here we are getting the difference of these two images. Similarly, this is the first image, this is the second image. After subtracting and applying some threshold, okay, this is the output. Now see, subtracting a constant value, or we can say the scalar value from an image, it causes decrease in its overall brightness. Okay, यदि आप किसी भी वैल्यू को सब्ट्रैक्ट कर रहे हैं, सब्ट्रैक्ट करने का मतलब है कि यहाँ पर कोऑर्डिनेट से कोई वैल्यू मान लीजिए 100 है, और यहाँ पर यदि आप सब्ट्रैक्ट करते हैं एक कोई कांस्टेंट वैल्यू है 5, यदि आप 100 माइनस 5 करेंगे तो आपका क्या होगा, यहाँ पर आउटपुट में क्या आएगा आपका, यहाँ पर इस पॉइंट पर 95. Am I right? So it means you are moving towards 0 or towards 1. किस साइड में मूव कर रहे हैं आप, ब्लैक और व्हाइट? हेलो, yes, any student in the class? Okay, 0.
Black.
So that's why I have written here, it decreases its overall brightness. Okay, so आप यहाँ पर देखेंगे, this is the original image, this is the original image. Okay, और आपने इसमें से x minus 75 किया है. इसका मतलब है कि यहाँ इस मैट्रिक्स में जितने भी पिक्सल वैल्यूज हैं उसमें से आपने क्या किया, -75 कर दिया है. ठीक है, यहाँ पर हो सकता है कि यहाँ पर ऑलरेडी 75 होगा, यहाँ इस कोने पर मान लीजिए एट दिस कॉर्नर, यदि 75 होगा तो 75 माइनस 75 क्या होगा, 0. दैट्स व्हाई इट इज ब्लैक. इज दैट क्लियर? ओके, नाउ द सब्ट्रैक्शन ऑफ इमेजेस is performed in the same manner as the subtraction of matrix. In case where y is an image of size equal to x and b will be the matrix of pixel map of y. So this is the similar which I have covered in the previous sections. Okay. I have taken here plus sign. Okay, so subtraction is a minus b. So this is your first and this is your second. So subtract this a11 minus b11. Okay, now for this element a12 minus b12. Similarly in this way. Okay. For this am1 minus bm1, this is the last element, this is the amn minus bmn. Okay, so this is the simple way to subtract the elements of image. This is also the similar way which I have covered. So when subtracting one image from another, or we can say a constant from an image, you must be careful with the possibility of obtaining negative pixel values as a result. There are two ways of dealing with this underflow issue. Treating subtraction as absolute difference, which will always result in positive values proportional to the difference between the two original images without indicating, however, which pixel was bigger or darker. So this is the truncating the result so that negative intermediate value becomes 0. So from here, this is the thing which I have to write 0. Okay, if you are getting in negative value, so you have to write 0. I have covered it. So the image processing toolbox has built-in function to subtract one image from the another image, or subtract a constant from an image. So this is the function ImSubtract, and again this image processing tool also has a built-in function to calculate the absolute difference. This is ImAbs difference, and the IPT also includes a function for calculating the negative or complement of an image, that is the IM complement. Okay, so these are the inbuilt function in the MATLAB. यदि आपको subtract करना है या complement करना है. Suppose I have taken here one example of two images. First image is the x, second image is the y, and it is 3y 3 matrix का है आपका 3 cross 3, 3 row and 3 column. Okay, so each of which represents an array of unsigned integers. Okay, so we have to apply here z it is equal to x minus y, z it is equals to y minus x, and z equals to modulus of y minus x. Okay, so पहली मेथड आपको क्या करना है, यूजिंग आई एम सबट्रैक्ट, दूसरा आपको करना है यूजिंग आई एम सबट्रैक्ट, तीसरी करना है यूजिंग आई एम दिस वन. So first you have to subtract y minus y from x. Are you getting? Hello, Abhishek, Divya Prakash.
Yes, sir.
Okay. So subtract 200 minus 100. क्या आएगा आपका 100.
100.
100 minus 220, it is minus of 120. Similarly, this 100 minus 2, it is 130, minus 130. Similarly, आप इसके 0 minus 45, minus 45, 10 minus 95, minus 95, 50 minus 120, it is minus 70, 50 minus 205, it is minus 155, 250 minus 100, it is 150, 120 minus 0, it is 120. Is that clear? Hello?
Yes, sir.
Okay. So it is for the A using I am subtract. हम इसको मैटलैब में यूज करेंगे उसके लिए. यहाँ पर हमने किया है z इट इज इक्वल्स टू x माइनस वाई. नाउ अब हमको इसको एक हमारा जो राइट करेक्ट फॉर्म है उसमें लिखना है. तो 100 के लिए क्या हो जाएगा आपका, ये 100 आ जाएगा. बट इफ यू आर गेटिंग in negative value, so what we have to write here, it is 0. ये क्लियर है आपको? Because we have a range here 0 to 255. Okay, am I right?
Yes, sir.
Okay. So again it is also 0. नेगेटिव वाली 0 वैल्यू हो जाएंगी सभी आपकी, ये भी 0 हो जाएगा, ये भी 0 हो जाएगा, एंड इट इज रिमेन द सेम 150. अगेन इट इज 120 120. ओके, so this is over. Similarly, now second task is y minus x. So now reverse operation, you have to subtract x from y. So 100 minus 100, 200, it is 100. 220 minus 100, it is 120. 230 minus 100, it is 130. 45 minus 0, it is 45. 95 minus 10, it is 85. 120 minus 50, it is 70. 205 minus 50, it is 155. 100 minus 250, it is minus of 150. 0 minus 120, it is minus of 120. So इसके corresponding आप value लिखेंगे. It is minus 100, so it will be 0. It is minus 150, it will be 0. It is minus 120, it will be 0, and other will be the same. Is that clear?
Yes, sir.
Slow. Here. Yes, is it clear?
Yes, sir.
Okay, should I move? Okay, so this is that it is equals to modulus of y minus x. So which is the y minus x? This one. तो यहाँ पर आपकी जो भी वैल्यू आएंगी ना, आपने जो जेड बी निकाला है, तो सी दिस जेड बी एंड जो भी आपकी वैल्यू है उनका मॉडुलस आप ले लीजिए. 100 माइनस में तो क्या हो जाएगा आपका, ये 100 हो जाएगा. रिमेनिंग क्वांटिटी सेम रहेंगी, माइनस वाली क्या हो जाएंगी, प्लस में आ जाएंगी. दिस इज द वेट. नाउ अप टू हियर, इज दैट क्लियर? एनी डाउट? शुड आई मूव? प्लीज फटाफट बोल दीजिए. हेलो,
Yes, sir.
Yes, sir.
So in MATLAB, we have created this X 200, 100, 100. First, this is the first row. After semicolon, 0, 10, 50, it is the second row. 50, 250, 120, it is the third row. So just write in the MATLAB, you will get this. Just write in the MATLAB for by. These are the values which I have selected. You will get this. Then this is the function I am subtract x comma y. Means this is x minus y. You will get this one. This is the I am subtract y minus x. You will get this one. This is the I am ABS difference. Okay, you will get this one. इसमें आपका जो मॉडुलस वाला आ जाएगा. Is that clear? ये मैं आपको ऑपरेट करा चुका हूँ इसकी पहली वाली स्लाइड में. कोई डाउट है यहाँ पर? Hello.
No, sir.
So this is the assignment. Note कर लीजिए. Create x and y, okay, of 3y3, okay, and perform the above operation using MATLAB. This you have to complete and submit. Now image subtraction can also be used to obtain the negative of an image. So this represents the complements. जहाँ पर आपका ब्लैक है वो क्या हो जाएगा आपका व्हाइट, मीन 0 क्या हो जाएगा आपका 1, 1 क्या हो जाएगा आपका 0. यस, क्लियर है ये?
Yes, sir.
Now this is the example so that you can understand it better. Comparing images using subtraction. Okay, this is the infrared image. First A. This is the B image resulting from setting to 0 the least significant bit of every pixel. This is the C difference of these two images, and it is scaled to 0 to 255 for the clarity. So subtracting one image from the other clearly shows their differences. Black means 0 and white means 1. Is that clear? So आपको ये समझ में आ रहा होगा कि ये आपकी दो इमेज है, दोनों इमेज का जो डिफरेंस है वो आपको यहाँ पर क्लियर समझ में आ रहा है. You can see here. Now it is also used in the mask mode radiography. है ना? Mask mode radiography. This is the commercially successful and highly beneficial use of image subtraction. And now it is using very much in the field of medical imaging. Okay. So this is this h of x comma y. This is the mask in the X-ray image of region of the patient body, and it is captured by the. I am not explaining it. Just this is the use. It is very much useful in the medical field also. Okay. So see, this is the image A. This is the image B. This is the image C, and this is the image D. Now this is the digital subtraction of angiography. Okay, this first is the mask. This is the mask. Second is the live image. आप ये live image है आपके डॉक्टर ने इसको कैप्चर किया है. ठीक है. Now C क्या है इसका डिफरेंस है दोनों इमेज का. And E क्या है आपका enhanced image. सो ये आपका मास्क है जो आपने बना के रखा हुआ है. ये आपकी डॉक्टर ने एक इमेज कैप्चर की है, लाइव इमेज कैप्चर किया है. इन दोनों का डिफरेंस क्रिएट किया तो ये इमेज आई है आपके पास में. और ये इन्होंने इस इमेज को एनेक्ट कर दिया है, ठीक है। ये आपका टोटल 0 हो जाएगा, यहाँ पर टोटल 1 हो जाएगा, 0 to 255 में। So it helps for the analysis of image in the medical field. Is that clear? Hello?
Yes.
है ना। इस इमेज को डॉक्टर देखेंगे और इस इमेज को डॉक्टर देखेंगे तो इस आई थिंक he will be able to analyze more details or to collect more information via this image. Okay. Now in the MATLAB, this is the IM subtract function, and this is the syntax that it is equals to IM subtract x comma y. This is the description. You have to use this description in the practical file also. Means subtract each element in the x in the array by from the corresponding element in the x, and it returns the difference in the corresponding element of the output array z. Okay, so this is the way. Again, this is the another example. I have created this x, this y, and this. Apply this function z, then we will get some answer here. Now this is the one example. This is our first image. Okay, and what I am going to here. See, I am read rice.png. I have loaded this image in the MATLAB. Estimate the background. Background I am open. This is the material part. So subtract the background from the image. जो भी आपका बैकग्राउंड है, तो आपने इस इमेज से सब बैकग्राउंड को यदि सेपरेट किया तो आपके पास में इमेज आ जाएगा। सिमिलरली I have subtracted one constant. Subtract the constant from an image. ये आपकी इनपुट इमेज है, आपने इसको लोड किया है। आपने क्या किया है कि i-50 कर दिया। i-50 कर दिया मतलब जहाँ भी जितने भी इसके एलिमेंट है 256 by 256 का ये मैट्रिक्स है, तो हर मैट्रिक्स की हर वैल्यू से आप -50 करेंगे, उसके बाद में जो नई इमेज बनेगी वो रहेगा। ओके, फिगर आई एम, सो दिस इज द j, दिस इज द i, I am so I, this is the I input image and this is the j output image after subtraction. क्लियर है ये आपको यहाँ तक का? हेलो?
Yes, sir.
Yes.
Question is over. If any student have any doubt, then please you may ask. Now, multiplication operation. So, an important application of multiplication and division is a shading correction. Like other image arithmetic operations, multiplication comes in two main forms. The first form takes two input images and produces an output image in which the pixel values are just those of the first image multiplied by the values of the corresponding values in the second image. And the second form takes a single input image and produces output in which each pixel value is multiplied by a specific constant. So the latter form is probably the more widely used and is generally called the scaling. Now the multiplication of the two images, it is performed in the pixel-to-pixel way in a single pass using the formula Q of I of j is equals to P1 of ij into P2 of ij. Okay. Now scaling by a constant is performed using the formula Q of I comma j is equals to P1 I comma j into C is a constant. So this is first image, this is the second image. We have multiplied to obtain Q. Again, this is the first image and this is the constant C, and after multiplication we have obtained this Q I of j. Note that the constant is often a floating point number and may be less than 1, which will reduce the image intensities. It may even be negative if the image format is supposed. If the pixel values are equally vectors rather than scalar values, for an example, color image, then the individual components For examples, RGB, red, blue, and green components are simply multiplied separately to produces the output value. Okay. If the output values are calculated to be larger than the maximum allowed pixel value, then there may be two ways. Okay. यदि आपने जो वैल्यू कैलकुलेट की है यदि वो आपकी रेंज है उससे ज़्यादा होती है तो आप क्या करेंगे? सो देयर आर टू वेज. फर्स्ट इज ट्रंकेटेड एट द मैक्सिमम वैल्यू. सेकंड इज they can wrap around and continue upward from the minimum allowed number again. So the image multiplication takes place pixel to pixel wise. In case where y is an image of size equal to x, b will be the matrix of the pixel map of y. So see, okay, so we have to change the sign here. So this is the first a, this is the second b, and we have to multiply it here in the same way. Okay, now take this is the example multiplication operation. Visible है? Okay. So take multiplication. This is the x 1, 3, 7, 5, 15, 75, 250 and 150. This is the y 50, 150, 125, 45, 55, 155, 250 and 75. So now first is x into y. Multiply this 1 into 50 it is 50. 3 into 150 it is 445. 7 into 125 it is 75. Am I right? Hello?
Yes, sir.
Okay. Similarly, multiply this 5 by 45, you will get 225. This 200 by this 200, this one. 150 by 75 is this one. So there are two ways. If you are getting maximum value beyond the limit, here it is limit is this one 0 to 255. So see for this, first is the truncated. 255 के बाद जो भी वैल्यू है उसको आप क्या काम करेंगे उसको सेट कर देंगे 255 पे. मैं टेक द मैक्सिमम रेंज में 255. So this is the similar. This is it will remain the same. ये आपका सेम रहेगा. Now this for 450 it is greater than 255. So take 255 only. It is greater than 255. So take 255 only. Again it is same रहेगा आपका. It is all these are greater, so 255, 255, 255, 255, 255. Is that clear? Hello?
Yes.
Okay. Now second thing is that another that is the this one G wrap around. Wrap around. So it is 50, it is 450, so it is 195. Now it is 110. ये कैसे आया इसको मैं यहाँ पर अभी कवर नहीं कर रहा हूँ. जस्ट अभी आपको यहाँ बताया था. This and this is the they can wrap around and continue upwards from the minimum allowed number. Okay. Now see multiplication operation. There are many specialist uses for scaling in general. So given a scaling factor greater than 1, स्केलिंग विल बी ब्राइटन. यदि आपका स्केलिंग फैक्टर ग्रेटर देन 1 है तो ये ब्राइटन होगा इमेज. इफ द स्केलिंग फैक्टर इज लेस देन 1 एंड इट विल डार्कन, तो इसमें ये ब्राइट हो जाएगा. तो दूसरे केस में डार्क हो जाएगा. Scaling generally produces a much more natural brightness or darkening effect than simply adding an offset to the pixel value. It preserves the relative contrast of the image better. Okay, so in the MATLAB there is a function IM multiply. Okay, this is what IM multiply. IM multiply. Okay, IM multiply. So this is the syntax that IM multiply. इसका करना x and y. So this is the description that it indicates that it multiplies each element in the array x by the corresponding element in the array y and returns the product in the corresponding element of the output j. Is that clear? Please go to जाइए finally.
Yes.
Ayush Chaudhary, Himanshu, Mayank Jain.
Yes, sir.
बेटा समझ में आ रहा है चीज आपको? It is very simple.
Yes, sir.
Okay, so apart from theory, I have also taken the MATLAB so that you can implement these in MATLAB. Okay, so it is very simple. ये lines जो लिखी है इनको देखकर आपको टेंशन नहीं लेने हैं. This is simple example. Multiply an image by itself. Okay, so this is the sentence. Read a grayscale image into the workspace and convert the image into this form. So this is the image. I know. And you also know I am read. This is a function moon.if. आप अपनी इमेज भी लिख सकते हो यहाँ पर, ठीक है? Then multiply the image by itself. Note that I am multiply converts the class of the image from 8 to 16 before performing the multiplication to avoid confusion the results. So इस तरीके से आपका रिजल्ट आएगा. ये आपकी इनपुट इमेज रहेगी और ये आपका आउटपुट इमेज रहेगी इस केस में. अनदर एग्जांपल, आपके पास में एक इमेज है, ये आपकी आई इमेज है, इसको आपने मल्टीप्लाई किया है 0.5 से. ओके, सो सिंपल सा एक तरीका है. आई एम मल्टीप्लाई ब्रैकेट में क्या लिखेंगे आप? आई इमेज है हमारी और कॉमा के बाद में किससे करना है? 0.5 से. ठीक है, इस वजह से रन करेंगे तो आपकी इमेज जे इमेज हो जाएगी ये, और ये हो जाएगी आपकी आई इमेज. आई, दिस इज द आई इनपुट इमेज. ठीक है, तो आपने इसको 0.5 से मल्टीप्लाई कर दिया तो आपकी इमेज ये हो जाएगी. ये क्या हो जाएगी? आपकी डार्क हो जाएगी इमेज से. क्यों? क्योंकि द वैल्यू इज लेस देन 1. हेलो, एम आई राइट? आपका जो मल्टीप्लाइंग फैक्टर है वो लेस देन 1 है तो ये डार्क हो जाएगा. यदि ये ज्यादा, एक से ज्यादा होता तो ये ब्राइटर होता. Now another example, this is your first image x, this is your second image y. Okay, हमने क्या किया है आप देख लीजिए यहाँ पर. दिस इज द ओरिजिनल इमेज. बी इमेज क्या है? इसको आपने 0.7 से मल्टीप्लाई किया है. मल्टीप्लाई बाय 0.7 तो ये आया. इसको डिवाइड किया है तो ये आया आंसर. ठीक है, सो यू कैन सी द इफेक्ट. दिस इज द मल्टीप्लिकेशन बाय कांस्टेंट 0.7. दिस इज द डिवीजन बाय कांस्टेंट 0.7. Now I have also taken another example. An important application of the image multiplication and division is shading correction. Shading correction. Now see, इस इमेज में और इस इमेज में क्या अंतर है? स्टूडेंट प्लीज देखकर बताइए. किसी से भी पूछ सकता हूँ, चेक कर लीजिए. व्हाट इज द डिफरेंस बिटवीन दीज टू इमेज? ए इमेज एंड सी इमेज. मनीष कुमार, मनीष कुमार, अभिषेक आनंद.
Yes, sir.
So what is the difference between image A and image C?
सर शार्पनेस बढ़ गया.
ओके, इमेज क्वालिटी बढ़ गई है ना, इम्प्रूव द इमेज क्वालिटी। ओके, द शेडिंग इफेक्ट, शेडिंग करेक्शन, यहाँ पर आप देख रहे होंगे थोड़ा सा क्लियर नहीं दिख रहा है, बस शेड दिख रहा है, बोलते हैं ना शेडेड है इमेज, है ना। आपने इमेज कैप्चर किया होगा तो थोड़ा छाया आ गई होगी किसी की, शेडेड इमेज है, धुंधली इमेज है ना। तो यहाँ पर क्या किया है कि आपने इस इमेज को टेस्ट, एक आपका शेडिंग पैटर्न उससे मल्टीप्लाई किया, तो आपने देखा यहाँ पर इसकी ब्राइटनेस इंक्रीज हो गई। सो दिस इज द एप्लीकेशन ऑफ दिस वन। नाउ दिस इज द अनदर एप्लीकेशन, सी another use of image multiplication is in masking. Okay, so this is also known as the region of interest. I think those who are working with the research project, okay, मैंने आपको पहली या दूसरी क्लास में भी बताया था मेडिकल इमेजिंग में, ये यदि मान लो स्किन कैंसर है यहाँ पर, है ना, कहाँ पर है, तो मेन जो रीजन ऑफ इंटरेस्ट मतलब जो मेन कैंसर वाला पार्ट है उसको ही सिर्फ हमको डिटेक्ट करना है और उसको ही सिलेक्ट करना है और उसको ही फर्दर यूज करना है। ठीक है, so this is the region of interest meaning here. Okay, so the another use is the image multiplication is in the masking. Okay, and this masking is, it is also known as the region of interest operation. So the process consists of multiplying a given image by a mask image. अब जो इमेज है ना उसको आप एक मास्क इमेज से मल्टीप्लाई करेंगे, that has ones in the region of interest and zeros elsewhere. Then you can see there can be more than one region of interest in the mask image and the shape of the region of interest can be arbitrary. So see, this is your image. Okay, now this is the region of interest mask which we have created a square. Okay, this is 1, this is 0. Okay, now multiply these two, we get this product of A and B. Okay, so आपने यहाँ देखा होगा इनपुट इमेज में आपका ये बहुत सारा पार्ट है, आर यू एबल टू सी दिस वन, बहुत सारी चीजें हैं यहाँ पर, हमको सिर्फ क्या पार्ट चाहिए, ये वाला पार्ट। तो दिस इज द रीजन ऑफ इंटरेस्ट, हियर मल्टीप्लिकेशन ऑपरेशन कैन बी यूज्ड। सो किसी को यहाँ तक कोई डाउट है तो प्लीज पूछ लीजिएगा। एनी डाउट? चमन लाल, चमन, चमन लाल, दिनेश नेहरा, जतिन कश्यप, कपूर आयुष।
Yes, sir.
Now, Kapoor Ayush.
Yes, sir.
Kapoor, please give one example
Yes, sir.
where this multiplication operation is used in the field of medical imaging.
Sir, तो स्क्रीन पे ये रीजन ऑफ इंटरेस्ट जो होता क्या है, जो पार्ट हमको चाहिए होता है खाली उस पार्ट, उस मतलब एक मास्क इमेज लेके उस पार्ट पे केवल 1 से मल्टीप्लाई कर देता है और बाकी जगह जीरोस कर देता है, तो जो पार्ट हमको चाहिए होता है वो मिल जाता है। और
एक
होता है
एग्जांपल दीजिए, मेडिकल इमेजिंग में आप कहाँ यूज करते हैं?
सर मेडिकल इमेजिंग का ही होता है ये मास्किंग, और तो दूसरा हो जाता है कि जब आपको शैडो करेक्शन करनी होती है।
ठीक, ओके। अभिषेक कुमार।
Yes, sir.
Yes, can you give any other example of this multiplication of image which is useful in the medical field? Yes. आकांक्षा परिहार।
Yes, sir.
Please give one example.
Sir, in the field for detecting skin cancer.
Okay. It is lovely good. Aditya Srivastava. Now, are you able to see this screen?
Yes, sir.
Yes, sir.
So I have typed here region of interest, medical imaging, then selected images. Okay. So this is the region of interest. Again, this part is showing the region of interest. Again, in the brain, this part showing the region of interest. So मेडिकल इमेजिंग में इमेज प्रोसेसिंग की हेल्प से डॉक्टर्स को ये डिसाइड करने में हेल्प मिलती है कि कैंसर कहाँ डेवलप हुआ है, कैंसर का साइज क्या है ना. Now in this diagram, see this is the region of interest. Yes, दिखाई दे रहा है आपको?
Yes, sir.
Yes, sir.
So शायद ये आपको क्लियर हो गया होगा. Now see this is the region of interest. So image में भी आप any type और image में भी आप skin cancer, image में भी आप brain tumor with other brain tumor detection. Okay. So I think it is clear. Now next is the division operation. आप लोगों ने मिनी टेस्ट दिया था, उसके मार्क्स आपको मालूम है क्या?
Yes, sir.
Okay. So next is the division operation. The image division operation or operator normally takes two images as input and produces a third whose pixel values are just the pixel values of the first image divided by the corresponding pixel values of the second image. So this is the simple division. You have to divide pixel of one image by a corresponding pixel of the another image. So many implementation can also be used with just a single input image, in which case every pixel value in that image is divided by a specified constant value. So division of the two images is performed in the OBS base in a single pass using the formula. So this is the similar which I have taken for the multiplication also. This is the P1. Yes. Yes. क्या होगा? कोई डाउट है किसी बच्चे को? So this is the formula. This is the P1 I comma j, and it is the operator division P2 I comma j. And if I want to divide this P1 I of j by a constant, so this is the operator, and this C represents the constant. So these are the way to do this way. Division by a scalar is often used to perform brightness adjustment on an image. So you can adjust your brightness. If the pixel values are actually vectors rather than scalar values, for an example, color image, then the individual components like red component, blue component, and green components are simply divided separately to produce the output image. Okay. The division operator may only implement integer division, or it may also be able to handle floating point division. If only integer division is performed, then the results are typically rounded down to the next lowest integer for output. So this is again multiplication का sign होगा यहाँ पर आपका. Okay. So this is the example. दिखाई दे रहा है आपको? Is it visible?
Yes.
So this is image X and this is image Y, and this image X had 1, 3, 7 in the first row, 5, 15, 75 in the second row, 200, 50 and 150 in the third row. Similarly, the image Y, it has 50, 150 and 125 in the first row, 45, 55 and 155 in the second row, 200, 50 and 75 in the third. Now we have to perform the division operation. So write X operator Y. So the operator is the sign of division. Now it is equals to this our array. So the procedure is that you have to divide the element of X by the corresponding element of the Y. So right here it is 1 divided by 50 in the first position. Similarly, 3 divided by 150 in the second position. 7 divided by 125 in the third position, in the first row only. Similarly, 5 divided by 45, 15 divided by 55, 75 divided by 155 in the second row. Similarly, 200 divided by 200, 50 divided by 50, 150 divided by 75 in the second row. Now calculate the division of this. 1 by 50 it is 0.02. 3 by 150 it is 0.02. 7 by 125 it is 0.056. 5 by 45 it is 0.11. 15 by 55 it is 0.272. And this is 0.484. And this is 1, 1 and 2. Now, as we know, if the value is less than 0, so we have to write what? 0, 0, 0, 0, 0, 0 for this value, and this is 1, 1, 1, 1 and 2. It will remain the same. So is that clear up to here? समझ में आया? Hello?
Yes, sir.
Okay. So
Yes, sir.
during the operation may be addition, subtraction, multiplication, or division. Remember the 4 important points which I have explained in the starting of the arithmetic operation. Okay. So this is the process which we have applied for the multiplication of X and Y. So using MATLAB, you can also create this X and this Y, and you can also perform this X division by Y. There is an inbuilt function which I will explain in the next class. Okay. Is that clear? Any doubt?
No, sir.
Okay. आकांक्षा परिहार, अक्षित पनवा, आशुतोष चौधरी.
Yes, sir.
बेटा कोई डाउट है क्या यहाँ तक?
No, sir.
नहीं है तो ये हम चारों ऑपरेशंस कंप्लीट कर चुके हैं और आपके पास में मैटलैब सॉफ्टवेयर है, उसकी हेल्प से जो भी आपको मैंने अरे बताया है, किस तरीके से क्रिएट करना है, मैटलैब कोड बताया है, वो सभी चीजें आपको इम्प्लीमेंट करके देखनी है एक बार, है ना। सो एंड द असाइनमेंट व्हिच आई हैव गिवन टू यू इन दिस क्लास, okay, so another assignment is create x and y of 4 by 4 array, okay, and performs all the 4 operations, okay? This is the assignment. आप कोई भी आप array create करेंगे x and y, ठीक है, उसमें आप प्लस माइनस मल्टीप्लिकेशन एंड डिवीजन ये चारों आप परफॉर्म करेंगे, ओके, यूजिंग द मैटलैब, and you have to submit this assignment up to next week, okay. Now is there any doubt? Please you may ask, otherwise I am going to end the class.